So just by way of a little bit of a review, we've looked at so far the ultraviolet radiation, and we know that the ultraviolet is in the higher energy end of the electromagnetic spectrum, and ultraviolet radiation is enough energy to be absorbed by electrons and cause an electron to transition out of its energy level completely out of the molecule, which breaks the bond. The electron is ejected completely out of the nuclear sphere of either atom, and the bond is broken. And in the case of the infrared radiation, it's of a lower energy. It's not enough energy to knock electrons out of their energy levels, but it is enough energy in certain cases if there's such types of allowed vibrations that it will cause an increase in the vibration, and then that energy, when the molecule relaxes back down to its normal vibrational modes, then it will release back the infrared radiation. That's how these gases act like greenhouse gases. They absorb the infrared radiation. It doesn't cause the molecule to break down. You still have the molecule existing as, in this case, for example, carbon dioxide. It's just caused the molecule to vibrate more and at a higher amplitude. And so then that molecule is going to what's called relax back down to its normal vibrational modes and release back off that infrared radiation. So the infrared radiation is absorbed, it's trapped, and then it's re-released. Okay, so in that way the infrared radiation isn't able to just escape the atmosphere and just move out into the vast expanse of outer space. Instead, it's absorbed and then re-radiated. Okay, and it's going to be re-radiated in all directions, where it can then be absorbed by another molecule. It can, if it doesn't run into another molecule, it can be radiated all the way back down to Earth and be absorbed by the Earth. And that's how we trap heat. Okay, the molecule doesn't break down, just causes an increased vibration. Then the molecule is going to relax back down to its normal vibrational, what's called vibrational mode, and re-emit that infrared radiation. So that's how we trap heat. Just because it's interesting, I'll tell you about one more type of interaction with electromagnetic radiation with matter. In this case, microwaves have even longer wavelengths, lower energy. They're not enough energy to break bonds. They're not enough energy to eject electrons. It's not enough energy to cause vibration, a change in the normal vibration between an atom and another atom in a bond. But what it is, the right energy is, it's the right energy to affect rotational motion of molecules. So I started to mention before, there's different types of energy, different types of motions associated with atoms and molecules. And one is vibrational motion. That's the oscillating between distance between various atoms held as a solid or within molecules. And then there's translational, which has to do with how fast molecules are moving around. That's all about the kinetic energy of the molecule. And then there's this rotational motion, and that's how the molecule is spinning around in space or rotating around in space. Okay, so this molecule is literally rotating around and around, and that rotational energy is on line with the energy associated with microwaves. And so a microwave, if it has the same rotational mode, there's only certain rotations that are allowed, because energy at this level is quantized, so there's only certain rotational modes that are allowed. Then if the microwave is of the right energy, when it comes in contact with a molecule, it's going to increase the rotation of that molecule. And so that's how microwave ovens work. The microwaves that are emitted in your microwave oven are tuned to the exact frequency that is the rotational motion of water molecules. So this is a water molecule. So they're tuned exactly to that energy of a water molecule, and they cause the water molecule to rotate more faster and more and just more rotation. And so that rotation of the molecules, the water molecules, then rubs up against the other molecules that it's around, and that rubbing is like friction, and it increases the heat, increases the temperature of the surroundings. So that's why things with a lot of water will heat up nicely in a microwave, and things that don't have a lot of water won't. Okay, because it's the water that you're affecting. All right, so that's the end of the story about the interaction of electromagnetic radiation and matter. The big story that we're interested in right now was how vibrational energy, which is associated with infrared radiation, interacts with matter to trap heat in the form of the greenhouse gases. And so I think now we understand that there's a lot of different molecules that can act as greenhouse gases. We've talked mostly about carbon dioxide. And so now for the rest of the unit here, we're going to talk about why we talk about carbon dioxide more so than the other greenhouse gases. And also we're going to review a little bit about how you can quantitate exactly how much carbon, or predict how much carbon dioxide is going to be in the atmosphere. So we'll do that for the rest of the lectures in this unit.